In this video, I want to show you how you can use Kangaroo, a plugin in Grasshopper to um, design membrane structures or shell structures and work on the form finding of these kind of structures. First of all, I want to tell you that Kangaroo is a pretty comprehensive toolkit. And not only you can use it for form finding of structural systems, but also many other design works, such as, for example, designing fashion cloth or jewelries or any sort of like artistic products. But let's get started with a very basic example for form finding. First of all, I'm going to create a mesh. So I'm going to just create a plain mesh. Mesh plain. Here it is. It asks for the boundary, and then the boundary can be this rectangle. This rectangle is the XY plane. Dimensions between 10 to 100. 100. Okay. And it asks for the number of divisions. You can just simply say if I have this many number of the size for along the X, size along the V, just count it with the units that I have. Okay, so here we go. You can reduce the number of divisions for this mesh, but it doesn't matter. Now, the next thing is that I want to imagine that this surface is kind of like an inverted suspended surface, something like Eisler tried with a freezed membrane. He soaked the membrane in water and freeze them, and then used the hanging, created a hanging model, and then invert them, flip them, and used thin shells. Now I want to do that. To do this, we should define the load case, the anchor situations, which part of the surface should be anchored, and also the mesh itself. So what I'm going to do, first of all, I'm going to call for the loads. Here. Well, vertex loads. Since I want to create a membrane structure, I call for vertex loads, and it asks for the mesh and asks for the strengths. First of all, let me just set the units to meter. A question that may arise here when using Kangaroo is that what is the unit for this strength? Is it in Newton, kilonewton? So it goes with the unit that you set for Rhino. So if it's a metric system like meters, it goes with Newton. If it's an imperial system, it will be based on that. So I go with SI units and just say, well, a load between 0.1 and so this is a load case. And the next thing is defining the anchor points. Here, is that under the mesh, you can pick which part of your mesh you want to anchor. So if you want to anchor the mesh all along the points around the perimeter, I will call the naked points and say here is the mesh, and the naked points will give me the points all around, all within the mesh, but I just want the area. I'm sorry, the mesh, and then I want the points all around. So this, and if I turn this off, these output naked points gives me the points around the perimeter. So I want to anchor these points. So what I'm going to do, I'm going to go to goals, drop down list. Here is the anchor. Is that anchor? And I will drop it here and say, okay, this is the point. And it also has an input that what is a target and what is a strength. These two inputs are optional. So if you say, I want to anchor these points to a certain location, you can connect to the target point, and also you can play around with the strength. Right now, it's like 10,000 units, 10,000 Newton. So it's pretty fixed, but you can loosen that if you want. And then here is under the mesh, we also want to define what is the edge length for this membrane structure. So if this is the mesh, and you give it like a strength, you'll see that the length of the mesh will be the same as it is here. But later when we simulate that deformation, you will see that what would happen when we change the length factor. Now, the next step is to solve this problem. So this is actually the main component of the Kangaroo simulator. You can connect all the input values as the goal objects, like including the load, what is the mesh edge condition, and what are the anchors. Let's see what happened. Here is how you can see the result. Now, you can actually click a button. If whenever you want to reset, you can click on it and then redo it. So for example, if I change the strength, let's see what would happen. So it seems that I'm like pulling this structure much harder and harder. So I'm just gonna like reduce this strength. And then for the edge factor, it kind of defines how flexible these points are from getting stretched. And here is the anchor situation. Sometimes you want to play around with some input values and you want to avoid your computer from crashing. So that's a good practice to connect a Boolean toggle to this. So as you change the parameters, you don't see any change. But when you set it true, and then you should automatically get the same form. I mean, you can automatically get the simulator form. If not, you can just click on the button to reset the simulation. So make sure that this is off. To get the output, you can just, if you drop a panel, you'll see the output of Kangaroo is a mix of everything, like the vertices, lines, meshes, whatever you can imagine. So I would say explode. I will explode the tree, which is which gives me a separate outputs, and then I will drop mesh, and here it doesn't give me mesh, and that's because here it says the data conversion failed from line to mesh. That's because whatever I have here is just lines. And the question is why? So something that is important is using this show button. This show button can show you what is happening to your mesh. So if I drop this show and then also connect this to goals, I can see what is happening to this mesh thing. And then here, let me turn all of this off. I can get the mesh. So that's, I mean, the functionality of this show is kind of tricky because, well, you expect that I connected a mesh and then I should get the result. But what you get is just like the condition of vertices and lines and not a mesh. So to get the effect of that mesh, you should use this show, which I believe is a component that lets you trace what is happening onto this mesh. Now, let me just do a little bit of housekeeping. Group these. Now, with the same scenario, I can make some modifications to get a totally different form. Let's just turn this off. Now I have this mesh. Instead of anchoring all the points about the perimeter, about this, I want to just anchor the corner points. So I will go to the mesh and drop mesh corners and connect them mesh. And this gives me 4 corners. And I say I just want to anchor 4 points. Here, since I turn this toggle to false, ooh, well, I got something here. It seems that the strength is too high. So what I can do is I can reduce this. It's better. Okay. Now this shows the effect of anchoring just 4 points with the same with similar load, and you realize that that was too much because in the previous situation we anchored all the perimeter and we had that amount of stretch. Now we have just 4 points that are anchored, so we're expecting to get a greater stretch. So I had to reduce the strength of the load. Now here in this example, we can see actually the effect of the length factor. So if I increase the length factor, it means that I'm making it stiffer. And you see here, by increasing that, I'm trying to like make it a little bit stretched throughout the membrane rather than the edges themselves. Okay, well, it seems that I should also reduce this load to because it's too much. for this scale. All right. So here is the result. One other thing that you can do is to define a different edge condition and say that I want to anchor these edges along a certain curve and then load this membrane structure. So let's just do this. And I'm going to copy this, drop it here. Here I have the mesh component, and I'm going to get the edges. So what I'm going to do, I'm going to get, we have this rectangle here. And I'm going to explode the curve. So now I have 4 segments, and now I'm going to divide the curve. And I can divide it into, for example, 3 parts like this. And I want to move these 2 points a little bit upward and then use these like 4 points, 2 down and 2 up, as nerves of the curve, as nerves of the curvature. So what I'm going to do, I'm going to move these points. Of course, not all of them. Let's just say, well, actually, I can say what is the motion. So here I want to say unit. And this can be something between, for example, 1, 2, 5. And here we go. Now here, I'm gonna make a trick. I'm going to drop a panel, turn it to a multiple list, and I would say if this is 0, 1, 2, 3, index 0, 1, 2, 3 points, I'm going to multiply the z factor, the magnitude for the first and last points, 0. So this might be 0, then the next one can be like 4, 4, and 0. Right, and then I'm gonna multiply this factor. So you will see that these 2 points will sit on the on their own original place, and then these 2 will pop up. Now I want to like make it a little bit bigger, so I would say 7, 7, or 8. Let's go with even numbers. Okay, 8. So I move them up, and nerves curve. I would say these are the nerves for a curve. But since I want to create a continuous curve to make that edge condition a continuous edge, I'm going to just say join curves. Oh, wait a minute. So I'm going to just say, okay, this is the geometry. Now I have these curves, and then I'm going to connect the curves. So I'm just going to have 4 connected curves. So this is what I have. Okay, so this is where I created the edge. Now this time, I'm going to connect the edge to like the points along this naked vertices. So these are the naked vertices. And what I want to say, okay, take these points, just these points, and kind of see, kind of map them on along this edge. So I want to say closest point on a curve. Curve closest point. So I want to say these points, and this is a curve. So now I have a series of points along that curve, and now I'm going to anchoring those points. Okay. Now let's try it. Oh, that's a very tiny little thing. Oh, well, actually, I'm not seeing anything here. There we go. Just decrease this string. Yeah. Oh, okay. Something that I forgot to do here is that I should actually say that these are the points that I want to anchor, but here there is a target point. My goodness, it will take a while. Let's see what here. We get this kind of situation because of this lens factor. That was weird. So let's just make it as is. And here it is. Where are the points? Oh, that sounds quite strange. I think I'm missing something here. So apparently everything seems okay. Let me just track it. Okay, here are the points. Oh, I see. Okay. Well, this is the issue. I think I should flatten this, and there we go. We got it. The issue was that I had to flatten this curve. So then when I join the curves, all the curves are in one list and they're all connected together. If I do not flatten them, then they're actually separate entities. I mean, they can't really be joined in a very nice manner. So when I just flatten them, the output will be just one closed curve. In the previous situation, it wasn't. Now I can increase, oh, not this much. I can increase the strength some level. Oh, well, let's see. Okay, and now you can see the effect of anchoring these points and a certain curvature condition. And of course, I can change this geometry as I wish to play around with the forms that are developed. Okay, here are the three different conditions that you can create a kind of like a flipped hanging model using Kangaroo.